relations and functions. In previous video, we have discussed types of relations. In this video, we are going to continue with function. So let's see what is function. A function is a special relation where every object in the domain has one and only one image. Okay, so function is a relation, but it's a special types of relations with these requirements where every object in the domain has only one image. Let's see this example. Okay, now this is a one-to-one relations, and every object has one image. So this fulfills the requirements of functions, and therefore this is a function. Okay, one-to-one relation is a function. How about this one? Many-to-one. Now we can see that all the object has only one image. Even though a few of them share the same image, but it still fulfills the requirements here because every object has one and only one image. And therefore, many-to-one relation is also a function. What about one-to-many? One-to-many is not a function. Why? Because one object has more than one images. Yep. Because for functions, every object can only has one image. And this one, it has more than one. For example, B has 3 images, and therefore this is not function. Okay, so one-to-many relation is not function, and the last one is a many-to-many. Now for many-to-many, some of the object may have more than one images. For example, B has 2 images, and therefore it's not function. So many-to-many relation is not function. One-to-many relation is not function. Many-to-one relation, yes, is a function, and one-to-one relation is function. Okay. Now let's see this example. State whether each of the following defines a function. If the answer is no, state the reason. Let's see the first one. This is a one-to-one relation. Just now we learned that one-to-one relation is a function, and every object has one image. Yes, this is a function. The second one, this is many-to-one because B and D share the same image. This is many-to-one, and just now we learned that many-to-one relations can also be a function. So yes, this is a function because every object has only one image. Even though some of the objects share the same image, that's okay. Yeah, that's okay. So this is function. How about this one? This is many-to-many. This relation is many-to-many, and just now we learned that many-to-many is not functions. It's not functions. So no, this is not function. And why? Why? Because object C has 2 images. Object D also has 2 images. Okay, object C and D has 2 images, and therefore it's not function because for functions every object can only has one image. Okay, the last one. Now this is not function. Why? Because this object has no image. Okay, just now we learned that for the functions, every object must have only one and only one image. But this object has no image, and therefore this is not function. Okay. Reason: object B has no image. The notation of functions. Function notation is the way a function is written mathematically. Okay, how we write functions. The most popular function notation is f bracket x, and this is read as f of x. So this is the most common ways to write functions. And in this notation, this fx is the image. Okay, this is fx is the image, and x is the object. Yeah, fx is the image and x is the object in this notation. Now sometime you will come across notations like this to write functions, and in this notation f is the name of the function, and you can see that these 2 capital letters x and y. This tells us that in this function we have 2 sets of elements. And the first set of element is x, and the second set of elements is y. So for every functions, it forms an ordered pair, and its ordered pair is formed by an element x from the set x. So this is the object from set x, and by an element y from the set y, and this y is the image. Okay, and the arrow is read as is mapped to. So this function tells us that we mapped the elements in set x to y. Okay, so this is the meanings of these notations. Function may also be written as this one, f colons x arrow f of x. Okay, so again, this is the name of the functions. This is the object. Okay, this is the object, and then the f of x is the image. So we mapped object x to this image here. Okay, and sometimes we use y to replace f of x as the image. Normally we use f of x as the image, but sometimes in some working related to functions, we replace this f of x with y. Y equal to f of x. So these are the notations that we use in functions. Let's see this example. In the diagram to the right, set B shows the image of elements of set A. State the types of relations between set A and set B. Okay, we map 3 to 9 and negative 3 to 9, and we can see that 9 is actually the square of 3 and negative 3. And we map 2 and negative 2 to 4. Again, 4 is the square of 2 and negative 2. And therefore, the relation of these two sets is set B is the square of set A. Okay, so the relation is square of. Square of. Using the function notation, write relations between set A and set B. Okay, let's use f of x as a notation. Okay, the image is fx and the object is x, let's say, and therefore the function is f of x equal to x squared. Okay, f of x equal to x squared. This is the image. Okay, the image is equal to the square of the object. Yeah, this is how we write these functions. We learned that we can write functions in this way, fx and then arrow 2x plus 1. We can rewrite these functions in another notations which will make the mathematics workings easier. And the notation is f of x, f of x equal to 2x plus 1. Okay, so if you are given the functions in this notation, try to rewrite it in this notation. So this will make the mathematics workings easier. Okay, now in these notations, we know that x is the object and fx is the image. If an object is given, then we substitute this object into these notations. For example, let's say the domain of these functions. The domain of this function is, let's say, A. Okay. What about another one? Okay, let's say the second one, let's put it apple. Okay, apple. And the third one, let's make it a tree. Okay. Let's say these three are the objects of the functions. Okay. So if the object is A, so when x equal to A, if the object is A, then this function will become f A. Okay, we replace or we substitute x with A, so the object become A. Okay, and this become 2. Now x become A. Okay, in this case x equal to A, and therefore this substitute x equal to A. When we substitute x with the objects, normally we put a brackets. And in mathematics, when we put a bracket, it means multiplication, right? Okay, so 2 bracket A means 2 times A. This is not variables, so we just rewrite it plus 1. Okay, so or this is equal to 2a plus 1. 2a plus 1. Okay, so when x equal to A, so we substitute x with A, and then this is what we get. Now, how about the second one, the apple? So when x equal to apples, then we are going to do the same thing. Okay, so it becomes f of apple, and this is equal to 2, normally we put the brackets, 2 apples plus 1, or this is equal to 2 apples plus 1. Okay, so if the object is apple, this is how we write the functions. And how about the last one, when x equal to 3, yeah, math equal to 3, then the functions, okay, let's continue it here. Okay, let's draw a line here and then let's continue here. And when x equal to 3, then the function will become f3, yeah? f3 equal to 2 bracket 3 plus 1. Okay, and bracket means times. So 2 times 3, 6. 6 plus 1, and this is equal to 7. Okay, so therefore f of 3 equal to 7. Okay, so this is how we solve questions related to functions if we know the object. Now let's see this example. Given the functions fx mapped to 3x plus 2, find the values of f of 3, f of -9, and f of 1 over 3. Okay, and just now we learned that if we are given a function in these notations, we rewrite it again with these notations, f of x, and then equal to 3x plus 2. Okay, let's start with A. A, we are asked to find f3. F3 means that the object is 3. When the object is 3, then we substitute x with 3, and when we substitute, don't forget to put the brackets. So 3 bracket 3 and then plus 2, and then 3 bracket 3 means that 3 times 3, this is equal to 9, and plus 2, this is equal to 11. So f of 3 equal to 11. B, f of -9, f of -9. So we substitute x with -9, and then plus 2. Okay, so this becomes -27 plus 2 equal to -25. Okay, C, f of 1 over 3. Okay, so again we have 3, and then substitute x with 1 over 3, and then plus 2. 3 times 1 over 3 equal to 1. 1 plus 2, and this is equal to 3. Okay, so this is how we solve the problems like this. Now let's see another question. Given the functions fx equal to modulus 2x minus 5, find the values of f -1. This question is similar to the previous one, okay, except that it has a modulus here. So let's rewrite it here. Fx equal to modulus 2x minus 5. Okay, so we are asked to find f -1. So we substitute x with -1, and then minus 5. Okay, 2 times -1, this is equal to -2, and then minus 5, and therefore this is equal to -7. Okay, and you should have learned that modulus means that we change all the values of negative to positive. For example, -7, after modulus it becomes +7. So modulus -7 is 7. So equal to 7, and this is the answer. Another example, given the functions gx mapped to 5x plus 3, find the values of x for which gx equal to 28. Okay, just now we learned that we can rewrite this notations into gx. Gx equal to 5x plus 3. Now in this case, the gx, the image is given. Gx equal to 28. Okay, so gx equal to 28. normally when I substitute something, I like to put the brackets. Okay, in this case, if you don't put the brackets, it's okay, but normally I like to put the brackets. So gx equal to 28. We substitute gx with 28, and this is equal to 5x plus 3. Okay, so, and we are asked to find the values of x. To do that, we need to shift this 3 to the left hand side. It becomes 28 minus 3 equal to 5x, and therefore 5x equal to, so 28 minus 3 equal to 25, so this is 25, and therefore my x is equal to 25 divided by 5, which is equal to 5. Okay, one last question. So diagram to the right shows a graph of the functions fx equal to modulus 2x minus 3 for the domains 0 to 4. State the values of a. A is here. Okay, state the values of a. Now we can see that this is the object. Okay, this is the object. When the object is a, the image is equal to 0. Okay, so when the object is a, the image equal to 0. So let's rewrite these equations here. So this is for a, for a. So fx equal to modulus 2x minus 3. Okay, so from the graph we learned that when x equal to a, the image, this fx is the image, the image equal to 0. So we substitute fx with 0. Okay, and modulus 2 times a, okay, 2 times a, because the object is a, minus 3, minus 3. Okay, so modulus 2a minus 3 equal to 0. Okay, to remove the modulus, so what we do is that we put a positive negative here and 0. But anyway, because positive negative zeros is the same, okay, actually we don't have positive negative 0. Okay, so normally we do not put a positive negative here. We just straight away write that this is equal to 0. Okay, so 2a minus 3 equal to 0, and therefore 2a is equal to, now we shift this negative 3 to the right hand side, become positive 3, and therefore a equal to 3 divided by 2. Okay, so this is how we find the values of a. So a equal to 3 over 2 when fx equal to 0. Okay. B, we are asked to find the range for the corresponding domain. The range, the lowest value of the image is 0. Okay, that is when a equal to 3 over 2. Okay, and the highest value will be this one. Okay, which we still don't know yet. Okay, what is this? Okay, so we don't know the value here, but we know that at this maximum values of y, or the maximum values of the image, it happens when our object x equal to 4. So it's when x equal to 4. When x equal to 4, so our fx will become modulus 2 times 4 minus 3. Okay, so it become 8 minus 3, which is equal to 5. Okay, which is equal to modulus 5, and modulus 5 is equal to 5. Okay, so when x equal to 4, our fx, our image, or our y is equal to 5. So this is 5. So this is 5. Okay, and therefore the range for fx, the range for the image fx, fx, it must be greater or equal to 0. Okay, the lowest values of the image is 0, and the highest value for the image is this one, which is 5. 5. Okay, so so the range is 0 to 5.